A new roller coaster ride has been created where a massive spring launches a 50-kilogram roller coaster. The spring has a spring constant of 1,000 newtons per meter and is compressed by 0.5 meters. The roller coaster is on a 20-meter hill, and at the top of the second hill, the coaster speed is 5 meters per second. How high is the second hill? So I drew a picture here with the spring and the two hills, and these two lines denote the heights of the hills at their. So this one is the first hill is 20 meters. The second one is the one we're trying to find. So I have it as h times m, so height times meters. And this is the speed of the roller coaster at the top of the second hill, 5 meters per second. So what we want to do is we want to use the law of conservation of energy twice. The first time to find the speed of the roller coaster at the top of the first hill, and the second time to find the height of the second hill. So the law of conservation of energy is the sum of the energy initial equals the sum of the energy final. So for the first equation, we're going to use the two formulas. The first one being the elastic potential energy, and that's equal to the kinetic energy. So 1/2 spring constant times the amount the spring is compressed equals 1/2 mass times velocity squared. So after plugging numbers in, we get 1/2 1,000 newtons per meter multiplied by 0.5 squared equals 1/2 50 kilograms times velocity squared. So after we simplify a bunch, we get 250 equals 50 v squared divided by 50. 5 equals v squared square root, and the velocity at the top of the hill, first hill, equals 2.23 meters per second. Now, we want to use the law of conservation of energy the second time, this time using gravitational potential energy plus initial kinetic energy equals final gravitational potential energy plus final kinetic energy. So that would be mass times gravity times height plus 1/2 mass times velocity squared equals mass times gravity times height plus 1/2 mass times velocity squared. This is final, and this is initial. So what's nice about this is that all the masses cancel out because all the masses cancel out basically, and what we're left with is, once we plug in numbers, is gravity, so 10 meters per second squared multiplied by 20 meters plus 1/2 50 plus 1/2 because the mass is canceled out. This is using the new velocity that we just found. So 2.23 squared equals 10 meters per second squared multiplied by the height we're trying to find plus 1/2 5 squared, 5 meters per second squared. So after simplifying, we get 190 equals 10 times the height divided by 10. The height equals 19 meters, and that is the height of the second hill.